In this short video, I want to tell you about some differences between discrete and continuous random variables. There are several differences. We know that continuous random variables have probability density functions, which help us calculate the probability, and that's what gives rise to some other differences. So let's let y be a discrete random variable. So y can be the number of answers that you get correct on an exam, multiple choice, where you're just guessing. This is the example that we played with last week. So y would take on discrete values 0, 1, 2, through n, where n is the number of questions on the exam. The probability that y is less than or equal to a number, let's just say 12, is not equal to the probability that y is less than 12. Those are different probabilities, and we're remembering that, but we know that before. Also, in this example, the probability that y is less than 12 is the same as the probability that y is less than or equal to 11, because y is discrete. So if it's less than 12, the next biggest number it could be would be 11. Those probabilities have to be equal. Now it's a bit different when we think about a continuous random variable. We'll let x equal the height. I wrote weight, but of course you know I meant height, of American males. Then the probability that x is less than or equal to 72 inches, well, in terms of the PDF and the definition of probability for a continuous random variable, it would be the area under this PDF curve. Now this is the PDF for x, so it's bell-shaped. The high point is above mu, which is 69.5, and over to the right is 72, and the probability that x is less than or equal to 72 is that area to the left of x equals 72. So that's the area I'm shading in right now. There's your probability that x is less than or equal to 72. Now let's consider the probability that x is strictly less than 72. This is also an area under the PDF for the normal random variable. So let's sketch it out. And it looks symmetrical, and the high point is right over the mean. Mu equals 69.5. And over to the right is the value 72. And less than, strictly less than 72 would be the area all the way from the left up to, but not including, the number 72. Well, now in terms of area, that's no different from what's above. It doesn't matter if you include the boundary in an area or not, because the boundary has zero area. So the probability that x is less than 72 and the probability that x is less than or equal to 72 are in fact the same. Now there's one other thing I want you to be sure you understand about continuous random variables and their probability, and it's a consequence of what we've just pointed out. The probability that x is equal to any particular value, we'll just say 72 again, that probability is equal to 0, and it must be. Let's think about how we define probability for a continuous and what the probability x equals 72 would actually mean. So we've got the PDF curve, and in the middle of it is mu equals 69.5, and off a bit to the right is 72. The probability that x is equal to 72 would be the area beginning at 72 and ending at 72. It would be the area under the curve between 72 and 72. Well, that's a width of 0. So it really doesn't matter what the height is there. The width of that rectangle would be 0, and the height would be the value of the PDF at 72, but 0 times whatever that height is going to be 0. So the probability that x is equal to 72, that's going to have to be 0. The probability x is equal to 70, likewise 0. The probability x is equal to 80, likewise 0. Thank you.